Hey everybody, we're going to look at confidence intervals when you do not know the population standard deviation. We're going to switch from a Z cutoff to a T cutoff or a T interval. I will probably make a quick video later of how to do these on the TI-84 just so that you have examples in both SALT from WebAssign and your graphing calculator, give you the opportunities to succeed on this section. We have 9 data points given. These are tree ring dating X values, and we're going to try to estimate the actual population date by using a confidence interval. So when we open up SALT, these 9 values are going to populate into our chart right here. We're going to go to descriptive stats first because the first 2 boxes we're asked to come up with the mean and the sample standard deviation. So I'm going to copy and paste the mean. Sample standard deviation, that's right here. Notice N is 9, that's for 9 data points. And I'm going to paste that S value there. All right. The T cutoff, it's important to know your sample size. In this case, it's 9. To get a T cutoff on SALT, we're going to go to Distribution Calculator. From the drop-down menu, select T Distribution. Make sure that between, since we're doing a confidence interval, we need, in this problem, the 90% in the middle. See how I did that? Put that in the area box. Grab your positive cutoff value, and that's your T sub C. Cutoff T value. Rounding to 3 decimal places, that's going to be 1.813. Now grab your calculator, and we're going to calculate the maximal margin of error. When we did the Z interval, it was the Z cutoff times sigma divided by square root of n. The only thing that changes is we're going to use that T cutoff, 1.813 times S instead of sigma. We only know the samples deviation. So multiply that by 24.3093. And then when you divide that by square root of n, which is square root of 9, you're basically dividing by 3. And I get 14 point, rounded to the nearest whole number. That surprises me. I actually have 14.6, so I'm going to call that 15. Lower limit is x bar minus e. So 1290, which that's the nearest whole number, minus 15. That gives me 1275. And then the upper end is x bar, 1290, plus your margin of error of 15. Excuse me, that's 1305. And I'm going to check it. So let's see, 90% confidence interval. I wonder where I got that wrong, because it's weird because everything else is right. To 3 decimal places. Let's see, the T cutoff. That is so weird. Oh, I know what I did. I didn't put an 8 there. It's a common mistake. We had 9 data points, minus 1 is 8, degrees of freedom is 8. So I'm going to grab this again, go back, I'm going to paste that in here, and then now round to 3 decimal places. The 9 makes that a 6. Now it's going to be good. There we go. Be sure your degrees of freedom box is 1 less than the size of your sample or number of data points. Number 2, do you want to own your own candy store? Let's see, with some interest in running your own business and a decent credit rating, you can probably get a bank loan on startup costs for franchises such as Candy Express and the rest of those candy stores. Startup costs for a random sample of candy stores are given below. Assume that the population of X values has an approximately normal distribution. And we're asked to find all that same stuff, but this time with salt. Notice there's not a cutoff or an E in this one. We got to be careful. Now to get X bar and S, we're going to open these up. Your table is populated with those values. Descriptive stats. And we're going to need to get the mean. And that's our X bar. This sample standard deviation. That's that number. Let's grab it. Make sure the rounding's good. 4 decimal places. 4 decimal places. We're okay. Now, here's where we got to be careful. I'm going to grab a pad and pen. Okay, margin of error, E, is my T cutoff value. 1, 2, 3, 4, 5, 6, 7, 8, 9 values again. Go to distribution calculator. Select T distribution. 9 minus 1 is 8. That's our degrees of freedom. Between 90% confidence interval, so I'm going to set the area at 90. And it, lo and behold, gives us the same cutoff T value. I'm going to copy. Actually, I don't have to enter that, so let's see. Let me just write that down. TC is 1.8595 times S, which is 31.0363, divided by square root of 9, or just 3. Okay, so let's make this E calculation. Capital E, or your maximal margin of error, is 1.8595 times 31.0363 divided by square root of 9, or 3. I get 19.237. Now the lower limit is X bar, which is 108 minus 19.237. 108 minus 19.237 is 88.76. We're asked to round to 1 decimal place, so it's 88.8. On the upper end, we have 108 plus 19.237. To the nearest tenth is 127.2. And so we're 90% sure that the actual mean of startup money is going to be somewhere between these two dollar amounts. The headache of number 2 is that you don't have boxes for cutoff T or E. So if you're going to use this particular software, you're going to need to write these values down, because you have to know the cutoff in order to find E. And then finally, number 3, what percentage of hospitals provide at least some charity care based on random sample of hospital reports from eastern states? The following information is obtained. Units and percentage of hospitals providing at least some charity care. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points here. 10 data points here. All right, so pull up our data, descriptive stats. The average is 62.3. copy, paste. Our sample standard deviation is 8.0342. I'm going to copy and paste that. Like number 2, we don't have a prompt for a T cutoff or a margin of error. So I've got a notebook here in front of me. I'm just going to sketch them down. When we go to distribution calculators, T distribution, we had 10 data points, so our degrees of freedom was actually going to be 9. We're looking for a 90% confidence interval. So between and 90. We get a T cutoff and I've got to write this down. So E is going to be 1.8331 times standard deviation of 8.0342 over square root of 10. Let me grab a calculator real quick to handle this. Sorry for the delay. I had to go grab my calculator. All right, so we have, for the margin of error, our T cutoff was 1.8331 times the sample standard deviation of 8.0342 divided by square root of 10. I get 4.657. So E is 4.657. Our lower limit is going to be 62.3 because it's your average minus E, 4.657. All right, so for my low end, I get 57.643 rounded to 1 decimal place, 57.6. For the upper end, it's X bar, 62.3 plus E, 4.657. I've got 66.957. Rounded to 1 decimal place, that's actually 67.0. Let me try it out. Very good. I'm going to post another video where we do these same 3 problems, but I show you how to do them on a TI-84, and it's pretty much a plug and play all the way.